Yes, go for it.
Right. Thank you, Umar. My name is Darren, and I have here with me Senthil, my colleague from Intuit. And today we want to talk about how at Intuit we have been using Cloud Custodian and other open source technology in order to streamline cloud governance across software development lifecycle. Talking about SDLC, here's a diagram of what a typical SDLC looks like. And we start off with the planning phase, then move on to design, code, test, build, and deploy, and then maintenance phase, rinse and repeat if needed. So how does cloud governance fit into this? Well, if you think about it, the goal of cloud governance is to empower developers so that they have the best tools in place so that when they build and deploy their not only their application code but their cloud infrastructure code, the end result are cloud resources that are compliant in terms of cost, security, and operational excellence. Traditionally, the way to do cloud governance is to have what we call policy enforcement at runtime. And recently, there has been more of a shift left mentality, which what Kapil has just talked about, is to then enforce policy earlier in the SDLC. For example, during maybe deployment time, during build time, or maybe even during the coding or the design phase. Um, and there are many moving pieces in order to support this, and it's more than just about shift left when it comes to how we can streamline cloud governance. There are many components that we need. Luckily for us, Cloud Custodian already provides some of the core functionality, which we're leveraging here into it. So for example, how do we define and implement the policies at code, have them execute at runtime, and have them remediate non-compliant resources? All of that is provided to us by Cloud Custodian. But then there's the build side of things, the deployment side of things. It's great to see Cloud Custodian starting to venture into those areas. But there are other functionality that we need to cover as well, because when it comes to cloud governance, there are many different users with different use cases. So for example, um, as a developer, I might care about my cloud resources in terms of their compliance statuses. So I might want to have a dashboard for reporting, or my manager might also care about that. And then as a cloud operators or a security team or cost optimization team, I might want to author policies and then test the policy that I write. How does that then get all put together in a unified experience, and then allowing way to handle exceptions? Because no matter how perfect cloud governance implementation is, there will always be scenario where a developer will ask for exceptions. So how do we handle exception handling? And then the orchestration layer is also needed, because how do we get policy to where they need to go and when and how they should be run? That's what the orchestration layer is for. And more importantly, how can we do all of this in an automatic fashion and doing it at scale? To give you some context into it, when we talk about scale, we have hundreds of policies of various types that need to be applied to thousands of accounts, where we have thousands of microservices whose source code live in thousands of various GitHub repos. So with that in mind, our goal, we set out to implement what we call policy engine platform, which we actually hope to open source soon. Not sure when, but until then, with this talk, we do want to share some of our finding and learning as we implement this policy engine platform. For this high-level architecture diagram, the main thing I just want to call out here is the platform sit integrated with our CICD pipelines into it. That way we have ways to stop and fail build and deployment to prevent cloud resources from being deployed if we ever detect non-compliant source code. Let us now start peeling the layers and look at things at the lower details. And to do that, first start by looking at policy. It's important to treat policy as code. With Cloud Custodian, we have that for free. Right? But up until recently, Cloud cloud custodian only support what we call runtime policies. What about the build side of time side of things? For us, we have been using the Repo policy language, which is part of the Open Policy Agency NCF project. It's great to hear that cloud custodian will soon support build time policy as well, because ideally it'd be great to have one policy language across the different SDLC. Talking about runtime versus build time, we highly recommend structuring your repo this way. Originally, we have one flat namespace where we put all the policies together. It gets really hard to manage, especially when you have to support different cloud providers or different infrastructure as code language. After storing things in repo, we also have to treat the policy as code when it comes to how we build them, how we package them. When we talk about build, we have CI in place so that anytime someone makes changes to the policies, we kick off PR builds. For cloud custodian, that means running a custodian CLI command to validate the schema and running functional tests on the policy using a local stack, for example, to validate the policy actually do what we want it to do. Once a build pass, the unit test and the validation pass, policies are packaged into a zip file, which we then send to an S3 bucket, which then eventually get imported into what we call the policy service, which is the policy catalog. From there, various users can see what policy we have available. Besides the policy content, obviously, we have metadata. These are the important ones that we want to call out that everyone should have. But the types of policy, the control ID this policy is associated with, remediation link, severity. We really hope cloud custodian can treat these metadata as first-class citizen. Until then, well, a lot of these metadata we have to specify as comments as part of the policy content, and then we have to parse it out and associate it when we import the policy. Moving on, I'll hand over to Senthil here to talk more about orchestration layer.
Thank you, Darren. Good morning, good afternoon, everyone. As the organization evolves and the policy development matures, so we'll be landing up in handling thousands of accounts, hundreds of policies in no time. And that's why we need an orchestration layer to deploy the policies at a scale. So let's start with the target groups, one of the few terminology that's used in the orchestration layer. So we group related accounts based on a rule, and we call them as an account targets. Even though those targets can be created based on ID and name, we highly recommend to use tags for creating those targets. It's a typical key value pair, and we can have different keys like an environment, business units, and we can create all the production accounts into a single account target, and the same thing we can do for development targets as well. We kind of apply the same approach to the policy targets. As you see, the policy, the cloud custodian itself does not use tagging at the policy level. So we kind of go with the generic approach where we use the first commenter line in the policy content to use as a tags. And our orchestration layer parses this data and creates the policy targets as shown in an example here. In this example, you can see a policy target is created with the key dev equal to set to true. So whenever the new policies are getting onboarded to the system, it's automatically added to these targets. So in this way, we can progressively roll out policies to the various environments. Next one is the rules. Rules is nothing but which kind of provides a mapping between an account's targets, policy targets, and the regions. And we also built in an approval mechanism so that an operator can create a rule, but the lead who can go and review the rules and see whether he can approve it. Next, please. There is a snippet of how the rules looks like, where you can see all the details about which account target the rules is kind of tied up to. And when at that point of time, when somebody is reviewing this, what are those associated accounts and the policies? You can see it from here, and approval has a good context when what are the things that he's trying to approve. Next comes the account onboarding. Account service is a part of orchestration layer which provides API to onboard and offboard accounts. There is a connector in front of account services which kind of helps to automate the onboarding process. It is nothing but a webhook which can be used by other tools like a ServiceNow or a script to automate the account onboarding process to the policy engine. So during this process, this connector creates the tags if it's not already there and associate these tags automatically with the accounts while onboarding to the policy engine. This is really useful for organizations with thousands of AWS and GCP accounts. So now that we know that we have a policy catalog and to have all the policies and accounts are coming automatically and we have rules in place, but what is the rules whenever there is a policy approval or an account is coming in, what happens is the rules does an evaluation and understand the policies that's already deployed in the systems and verifies the rules and creates a new payload, do the difference between what is there and what new things to be added or even the cleanup and it sends a request to the deployment service. Once the deployment service receives the request, its responsibility is to guarantee the deployment. Underneath, it uses the C7N for policy deployment. And also it makes an additional API calls using SDK to verify those policy resources are created properly. As we know, Cloud Custodian does not do the cleanup, so we kind of add it to the orchestration layer here where it can do an automatic policy cleanup using SDK. The deployment service have a built-in resiliency, which is kind of a configurable retry options where we can say it can make a number of attempts before it calls us a failure. There may be a situation like an throttling or an access issues where you like an operator can go back and fix those things, and then he can come back to the UI and re-trigger the failure deployments based from the orchestration layer UI itself. From a scalability point of view, behind the scenes, all these things are running in the as a worker, so we can increase the number of workers as we need. So whenever we deploy a policy to a set of like an all dev accounts, it's kind of we are talking about a 30K deployment request, which is getting sent to the deploy service, and it's kind of the entire end-to-end. It takes around like a 25 minutes to get all the policies deployed into like a 30K different combination. The next comes is the multi-cloud support. As you see here, we are hosted in AWS. So when the accounts are automatically onboarded, so during the setup process, there is a predefined role which is part of the target accounts. So these roles has a trust relationship between the policy engine account, so that it's whenever as soon as the accounts comes on board and it get onboarded to the policy engine, it automatically start getting the policies based on the rule evaluations. And you can also see we use the same hosting for deploying the GCP policies as well. The GCP, it's a little bit different. GCP uses service account and also it provides a service called workload identity federation service. And we have to do a one-time binding between IAM policy and workload identity pool. And also with the help of service account, we are able to deploy those C7N policies to multiple GCP targets. And one thing I want to highlight here is like, we don't have to create service account for each of these target accounts. We can have one service account at an org level, which has the permissions to create the cloud resources for the policies. Next. So now that we know for the larger audience, like the C7N, when it's deploying the policies, right? Behind the scenes, it creates the resources like a Lambda, config rules, and CloudWatch events. So all these resources are run at a different interval to do the evaluations and send the notifications. But how do we protect these policies from accidentally getting removed by some users? So that's where we use AWS Service Control Policy, which we call it as an SCP, which is an organization level policy to manage permissions at organization level. It offers a central control over the maximum allowable permission for all the accounts in the organizations. Here is a sample of the C7 Lambda and CloudWatch event protections that we have. It's an explicit deny for the operations like updating a function or deleting a functions. These are applied at the resource ARN which has the prefix of a custodian. And you can see from here that only the role with the policy engine role have permissions to make these actions. Other roles may not be able to update or delete functions here. This sample is for config rules. It's slightly different because the way the config rules create the resource ARN, it may not have the prefix for the custodian. So we kind of rely on the tagging, the policy engine tagging, to make that actions where we only policy engine role can make the config rule delete or config rule update, the others cannot have it. Okay, so now so far we have seen how we can deploy policies at a large scale and also how we can protect those policies. Now we want to see how we can have some reportings which can help the operator as well as the developer. So this is a page within the UI that you can see which helps the operator who is trying to deploy policies at a large scale. And he knows even though we have a guaranteed deployment, it tries for n number of times, but there might be situations like a cross-account role access issue, or there could be a throttling running for an hour, which finally the deployment worker will give up and started putting those things in the UI here. And from this UI, the operator can initiate a retriggering the deployment request from here once he feels the issues are fixed. And also the issues like a cross-account role access, we explicitly call out in the error so that people know what action that they need to take. In addition, we also have some Splunk dashboards where people can track how many requests the deploy service got it and how many are attempted to make to deployed and how many are success and failure. This gives a higher level number which we can reconcile. But if we feel that there is some errors, people can use drill down from here to troubleshoot further. So the next dashboard is also part of an orchestration layer UI, which is used which is targeted for both for operator as well as some security team member, where they can kind of identify the list of policies deployed at each account level so that they can do an audit. So the next one is primarily for the developer, where it's a built-time things, and developer, as soon as he creates the resources as part of a cloud formation or Terraform, he needs to know right away if he's doing something wrong. So let's say an example, when a new developer joins the team and he's trying to create resources, and he may not be aware that he's violating some policies. And these things are integrated with our CICD. So as soon as there is some violation happens, automatically it's kind of the build gets failed, and also it provides a link for the build time report. As you can see the report here, it provides all the policy metadata informations like with the control ID, the policy which is getting violated, and the remediation link where the developer can go and read and take the necessary actions. So the next one is then another dashboard which is outside the orchestration layer, but this is also really handy for the developer where he can see all the runtime violations that he is responsible for. This dashboard provides all the information for his accounts and the controls and the evidence data, what it is violating. And also it provides a link for the remediations where he can take some action. With that, I will turn it to Darren.
So from a developer point of view, they have reportings, dashboard for their cloud resources and the compliance statuses of things. I can guarantee you, there will always be use cases where developer will ask for exception. Hey, I cannot fix it, and so we do have to handle exceptions. And there are two ways we can do exception handling with Cloud Custodian. I mean, on the build side of things, is implemented very differently. But for today, let's just focus on Cloud Custodian. And there's two ways. I refer to them as in-policy exceptions versus out-of-policy exceptions. With in-policy exception, as the name implies, the logic is inside the policy itself. Let's look at this example. This policy say we will stop Redshift cluster if we detect that it is unused for the last 7 days. And here we have exception handling via a filter that say, hey, let's skip the resource, the bad resource, if it has a tag that say cause of exception set to true. Here's another way to do in policy exception. Instead of using tag, it can actually reference an approved list of resources that has been approved for exceptions that is stored in S3. This is actually the preferred way as versus compare the tagging way, mainly because with tagging, anyone can just put this in place and all of a sudden the resources are no longer being scanned and evaluated. Here, somebody has to approve the request for exceptions before we skip over it. Then for out-of-policy exceptions, obviously it's not within the policy itself, and for us, we treat it at the orchestration layer. And for that, we provide a way to say when we orchestrate what policy goes where, we can say, don't deploy or or please exclude this policy for a list of given accounts regions. It's not as granular as in policy exceptions, since we're dealing with things at the account level regions rather than the resource level. But it's a powerful way to help the team in determining what policy should be or should be excluded from their cloud environment. So with that, let us just wrap everything up by revisiting the diagram of a typical SDLC here. Hopefully from our talk, you can take away that it's more than just, when it comes to cloud governance, it's more than just where can we enforce policy, right? Whether it's start with a maintenance phase or shifting left, there's more than that. There are different use cases for different users. And we have to provide a unified experience for all of those use cases. We have built together policy engines, but many of the functionality are leveraging Cloud Custodian. And we're excited to see Cloud Custodian starting to expand its scope. And we look forward to see what's in the future for Cloud Custodian, and highly encourage everyone to contribute to Cloud Custodian. With that said, we will now have some minutes for Q&A.